So we've looked at arithmetic and geometric sequences. Now what we're going to begin to take a look at is how to sum them up. So we need some notation that you've probably seen before, but it will definitely be an important idea as we move into calculus. And the idea is the summation sign. What we're going to do here, this means we're going to do successive iterations. We're going to do iteration after iteration. First, we're going to do the first iteration, the second iteration, the third iteration, and then this big crazy looking Greek E is going to mean we're going to sum them up and literally add them. So let's take a look at how to do it. So this summation notation says we are going to start with the third iteration. So down here is where you start and up at the top is where you're going to. So we're going to do the third iteration and put that in for k. So that would be 3 squared. Then we move to the fourth iteration, 4 squared, 5 squared, 6 squared. We stop at the top. So 7 is our last iteration. Okay, do all our math, and this sign is the summation sign. I mean, we're going to add all of those iterations up and get 135. So let's try one here. So what we're going to do here is we're going to do that first iteration, 3 times 2 minus 1. So I get 6, I get 5. Now we're going to move to the second iteration. We're going to do 3. So we started at 2, now we're ready for 3. So we get 9 minus 1, we get 8. Now we're going to go to the fourth iteration. So I've got 12 minus 1, I've got 11. And then lastly, we're going to stop at the fifth iteration because the top tells us that's where we're done. So I've got 15 minus 1, I've got 14. Okay, the summation sign says add all those up. And when we do, we're going to get 38. All right, now that we understand the summation, we're going to talk about how can you add up the first so many terms, iterations, of an arithmetic sequence. And then we'll do the same for geometric in just a second. Now, the formula for this is not intuitive. It is derived from a clever little math trick. We're going to see that for both of these series. So I'll leave the proof, and it's in the book here, but it's not something you could naturally see, and it doesn't have a simple explanation. So basically, a math trick has proven that this is the value of the summation. So let's take a look at how to do it. So we're going to sum this here. It's arithmetic sequence because they have a difference of 3 every single time. So our formula says you're going to take the first iteration and the last iteration that you want. So here's our first one. Here's our last. We're going to add those together. We're going to multiply it by how many iterations we had. We had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n was 10. And then lastly, we just divide by 2. Now, when we look here at B, we have an extra problem. All they told us was the first and the last, and we do need those, but we aren't told what number iteration we're on, so we need to find that out. So our formula requires us to have the value of n. Well, we don't know what iteration negative 50 is, but we've learned how to do that before. If you remember in our previous video, here's how we could do that. So we have an arithmetic sequence with our final term. Here's our first term, plus n minus 1 times that difference. I won't rehash all of that, it's in the old video, but this gives us everything we need to find n. I know negative 50 is the last iteration. I've got 20. I've got n minus 1 times that difference of negative 5. So I guess on this sequence, remember, we would have done this one minus the previous one to find that our difference is negative 5. 15 minus 20, 10 minus 15. So our difference is negative 5. Okay, now we have everything but n. We can solve for it, and we find n is 15. Now, why did we need that? Because we needed the first iteration, which we had, the last iteration, which we had. We're going to divide by 2, but we also needed what iteration we're on, the 15th iteration. So plug it in, crunch our math, and these first 15 terms sum to be negative 225. Okay, let me see, I can't remember what we did. Okay, so we have the summation sign here, but we want to use our formula. You could literally do this if you wanted. You could create all 12 iterations and just add them up yourself. But this is an arithmetic sequence, so we are going to be able, we just keep subtracting 8 each time. So we're going to use our little shortcut. So first we're going to need iteration number 1. So we put that in our formula, and we've got iteration number 1. Now we also need iteration number 12. So we put 12 in, crunch that down, we've got 28. Well, now we have everything we need. We've got n was 12. We've got our first and last iteration, and you divide by 2. And there you go. 138. Oh no, let me check something. Yeah. The challenge here on this, to see that this form is an arithmetic sequence is a little difficult, but in this case, they told us that this was an arithmetic sequence, so we knew that we could be using the summation formula for this. Okay, so let's try some on our own. So we need the number of iterations. We need n. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I've got 11 iterations. A1 is going to be 1.4. A2 is going to be 3.4, or A11, I should say, our last iteration. So here's our formula. It says take n, multiply it by the first and the last, added together, and then divide by 2. And you crunch this down, you're going to get 26.4. Okay, let's try again, but here we don't know what value of n, what iteration this 69 is. So first of all, we're going to need to find our difference. So we're going to take 21 minus 13, get a difference of 8. So we know A1 is 13, we know AN is 69, but we don't know how many iterations it's been. So what we're going to do is go back to our old original formula for an arithmetic sequence, which says this. You just take the first term and you just keep multiplying it by that difference over and over. So we know 69 is 13 plus our difference of 8, n minus 1. If we solve this for n, we've got everything we need for our formula. We've got 69 equals 13 plus 8n minus 8. Okay, so I've got it. N is 8. Now we have everything we need for the formula. It goes 8, the first one, plus the last one, all divided by 2. And you crunch that down, we'll get 328. Okay, let's try one that is in series form. Now they've told us it's arithmetic, so we know that we can use our formula. So what we're going to need here is A1. So I'll find that by doing 5 minus 6 times 1. It's going to be negative 1. So there's my first iteration. I also need the 10th. Well, I can find that as well. 6 times 10. So what do I have here? I've got 5 minus 60 equals negative 55. Okay, I've got the first iteration. I've got the last iteration. And I know there were 10 iterations. I know n is 10, so I have everything I need. So I've got 10 times the first one plus the last one, all divided by 2. And you crunch that down, you get negative 280. Okay, we've got some more applications here with arithmetic series. We've done this before, but now we're going to do it with this new idea of summing the first terms in the sequence. So this woman has surgery, and she walks a half mile. Then each week she's adding a quarter mile. So if we keep adding the same thing over and over, we're doing an arithmetic sequence. So here's what we got first. So here's our formula for an arithmetic. Our difference is going to be 1/4. Yeah, she adds an additional quarter mile. So she starts with this. She adds an additional quarter mile each week. Now, so we know A1 is 1/2 because that's what she just does before she keeps adding the quarter mile. So that's our initial. We know our difference is a quarter mile. They told us that. So let's find the 8th iteration in the sequence. So 1/2 plus 1/4. We've got the 8th. It's after week 8 minus 1. So just doing our arithmetic definition here, formula. And we crunch that down, and A8 is 9/4. Well, why did we need that? Well, our summation, if we want to know how many miles she walked in total, we need the first one, we need the last one, and then we're going to do the 8 iterations. So let me plug it in. Here's our first one. She did a half mile the first week. After 8 weeks, she did 9/4, and then iteration 8, and divide by 2. All right, let's try another one. So we're going to start here with our generic formula. Starts with $100, and then each week $12.50 is added. That's our D, and we do n minus 1. Now, in order to make this work, we need the following. We need A1, which is obviously 100. When he first starts, it's just 100. You could put this here. We're just going to start with that iteration. Now we need A12. We need what's going to happen after 12 weeks. So I'm going to put this in here. So this is going to be 100 plus 1250 times 11. Let me crunch that. Okay, so I got 237.5. So to find the sum of the first 12 terms, we're going to add up the first and last iteration. We're going to multiply it by the 12 for the n and divide it by 2. And we get $2,025. Okay, now don't forget, we saw this in the last section where they were kind of messing with whether they were starting with iteration 1 or 0. On these word problems, we're starting with 1, which is the way I want to do it. Again, in calculus, it's fine to switch it up, but we want to stay consistent. So for now, as we're first learning this, so they started with everything A1. They're not starting with n equals 0. So it all works just like you would think, and we get our answer. Now, let's move to the idea of the formula for the first terms of a geometric. Remember what geometric, so arithmetic, we keep adding the same difference every time. Well, with geometric, we keep multiplying by the same common ratio every single time. Now, again, this formula is not intuitive. It's a math trick that helps derive this, so I'll leave that into the book. But this is what we're going to need here. So basically, what you're going to need is, remember, R stands for that common ratio, and we're going to need the first iteration and how many iterations that were involved. So let's take a look at one. So we're adding, it tells us they're geometric series, so we don't have to distinguish that. We know they're geometric. So if we know that, we're going to do our first one here. We're looking for our common ratio, which is we just take the second term divided by the first. Now, they told us it's geometric, so I don't have to keep checking all of them. I know it's -1/2 because they told me it's geometric. Just take the second iteration divided by the first. So I have R. I know n is 11 because they told me that we're summing the first 11 terms. So, and the only thing else I need is the first term in the sequence. Well, that's 8. So I have everything I need. 8, 1 minus that common ratio, which was -1/2. N is 11, 1 minus -1/2. We've got everything we need. Crunch that down. And if you sum the first 11 terms of this geometric sequence, you get about 5.336. Okay, now they have told us that this is geometric. We know that. So we have the first iteration. It was 3. Let's see what they had here. Yeah, we're just, if we put k equals 1 in here, we would get 6. So that first iteration is 6. Now our common ratio, yeah, the common ratio here is not completely intuitive. If you don't see it, just create several values in this series. Like just put k as 1n, then k as 2, then k as 3, and you could find that common ratio yourself. But if you see it off here, what we keep multiplying each time by 2. So it's actually 2 that's going to be the common ratio. But let me see. I'm going to just do this over here. So if you didn't see that, if we put 2, 1 here, we get 3 times 2 is 6. Now do it again. Let's do iteration 2. That would be 4 times 3 is 12. So we keep multiplying over and over again by a common ratio of the second term divided by the first, but we keep doing it by 2, which is actually kind of hidden here in the formula. We keep multiplying by 2. But if you can't see that by that exponent, it means we keep multiplying by successive 2's. If you don't see that, just create a couple iterations, find the common ratio yourself. So r is 2. We're looking at the 6th iteration. The first iteration was 6. Crunch that down, and there we go. Okay, let's try this for S20. For it tells us it's geometric. We don't have to guess that. We know it. So let's find r. It's the second iteration divided by the first, so we've got 1/2. Okay, so r is 1/2. We know n is 20. We also need the first iteration, but they gave it to us. So we're going to sum this up. We get this. Hold on, I forget the formula. It's 1 minus 1/2 to the 20th iteration. All of that divided by 1 minus r. Okay, now crunching this down, just be careful of the order of operations. You've got to do this exponent in here first, finish what's inside of here, and then divide it by the denominator. When you've got all that, you can then multiply it by the 1,000, and what you get is approximately 2,000. Alright, so again, we are told this is geometric, but what we need is that common ratio, and I don't think it's all that intuitive to find here, so I don't think it, at least in my mind, it doesn't clearly make sense. So what I'm going to do is do a few iterations. I'm going to do 3 times 1 is 3. Then I'm going to do 3 times 2 is 6. And if I do a couple iterations, I can find r by just doing the second one divided by the first. So r is going to be 2. I know n is 8, and my first iteration is 3. So let's put it in the formula. It needs the first iteration times 1 minus r to the 8th divided by 1 minus r. Okay, crunch this down. Remember, you're going to do the -1 to the 8th power divided by -1 first. That's what you're going to start with. Oh, hold on. Let me check that I'm doing something right. No, I said this wrong. I'm sorry. This division bar carries all the way over here. So to finish this one, we would have done the entire top to the 20th power times the 1,000 and then divided it by the 1 minus 1/2. So do this number. So we're starting with this. Do that, subtract it from 1, multiply by 1,000, and then divide it by the 1 minus 1/2. So, sorry, I don't know that formula by the top of my head. So here what we're doing, no, I did that wrong too, hold on. It would be this, all divided by the 1 minus 2. So A1, 1 minus r to the nth power, which in this case happens to be 8, divided by 1 minus r. So we're going to crunch here first, subtract it from 1, multiply by 3, and then divide it by the 1 minus 2. And we get 9840. Okay, so we've got to end with a couple applications with geometric series here. So we saw this before. If they give us a rate here, this is not just 1.6. What we're going to be working with is 1.016. So our first iteration is going to be $26,750, his starting salary. Now r is going to be 1.016. That's how much it's getting multiplied by each time. So if you get a raise, it's got to be the amount you started with an extra 1.6 on top. So you're multiplying by 1.016. We're looking at the 5th iteration because it's the end of 5 years. Divide that by 1 minus 1.016. So again, all the way across, which I was not getting correct. So we're going to do the 1.016 to the 5th power first. Take that answer away from 1, multiply it by 26,750, divide it by this, and we get 138,099. Okay, let's try 1 again. So we're going to have, there's our initial salary. Now what we're going to do, so remember it's 2%, but it's got to be based off 100, so or 1, so 1.02. Like your salary has to go up. If it was just 2% of your salary, it'd be going way down. We're on iteration 8 here, and then we're dividing all of that by 1 minus 1.02. Crunch that down. We get a salary of $275,513, not bad. Must be happy with that salary. And you're done. Okay, so we've looked at how to sum up the first number of iterations in both arithmetic and geometric series. Hopefully it's pretty intuitive. So you're going to need those formulas. I don't have them both memorized myself, but hopefully you will, and that should get you going.